उधर ना
तो काटता हूँ मैं।
वो लैपटॉप चल रहा है।
हाँ
ओए मेरे को एडमिन बनायो। ओए राहुल काटे मार दे स्क्रीन पे। राहुल काटे मार दे स्क्रीन पे।
Yes, good evening everyone. Good evening guys.
Good evening, sir.
This is Praveen sir from Hyderabad. I'm going to teach you EDC and the analog part. Since the last 10 years I associated with Gate Revolution and I'm taking classes. From Hyderabad I'm taking EDC analog in ACE Academy and TAG. So today I would like to start the analog part, analog electronics. Yes guys, is my voice is clear?
Yes, sir.
All of you? Yes, right. First, I will give the syllabus for analog electronics. Are you ECE or any student from electrical or telecommunication background? Are you electronics or any student in class from electrical and telecommunication? Yes, all are ECE. Okay, guys. First, let me give the syllabus for total analog and ADC. Thereafter, I will discuss first part of analog in today's session. If any possibility, please note down the syllabus, guys. Yes, in GATE examination for EC students, total weightage is from from EDC and analog. Weightage they assigned minimum is 20 marks, maximum 25 marks. That is the reason most of the faculty they might say that EDC analog is most important for electronic students. Means 25% of the syllabus are marks. They are mainly concentrating only in these two subjects, guys. So EDC analog syllabus I am giving. Please note down the syllabus. First for EDC. Part 1 is semiconductor physics. Please copy the syllabus. Semiconductor physics. So in first part we have to discuss only 4 topics. First one is current components. Current components of semiconductors. Second one is energy levels. Energy levels. And the third one is case studies. Case studies. And the fourth one is Hall effect. And the last one is continuity equation. Continuity equation. These are the topics we have to discuss in first part. Weightage, average weightage marks, maximum 4. Minimum 3 marks, maximum 4 marks. Yes, guys. Part 2, second part, diode characteristics. Second part is diode characteristics. In this second part, we have to discuss. I'm going to discuss zero bias of PN junction diode. Zero bias of PN junction diode. Next, forward bias and the reverse bias of PN junction diode. Forward bias and reverse bias of PN junction diode. Next one is breakdown mechanism. Breakdown mechanism. Breakdown mechanism. Next, VI characteristics analysis. VI characteristics analysis. And the part 3. Part 3. Transistor characteristics. Transistor characteristics. Transistor characteristics. Guys, can anyone define what is transistor? Yes. Can anyone define what is transistor exactly? Is my voice is clear or not? Yes, someone is giving response. 3-terminal device used as a switch. Good. 3-terminal bipolar semiconductor device. Good. Any other answer? Yes, you can unmute your mic and you can give the answer orally also. Transistor is used for amplifying. Akritji, Kashyapji given as the 3-terminal bipolar semiconductor device. Pujaji given as the 3-terminal device used as a switch. Out of these 3, which is correct? Yes, one more answer. Yes. Yes, sir. 3-terminal of with the sandwich of 2 diodes. Good. Semiconductor device with sandwich. It's a 3-terminal device. Transfer resistor. Purti Jainji. Yes. Yes, what is exact? Signals are power for amplification used. Applications we are saying yes. Suppose if you secure and get 3rd rank, 10th rank, or 15th rank, or first rank, and if you attend the technical interview in IITs, NITs, or any PSUs, and if you face the same question, what is your exact gunshot answer, guys? For transistor, what is the exact answer? Suppose if technical resource person in IIT professor, he might be professor, he might be GM or DGM or DA or AE. If he raise the same question, what is your answer? Yes. It's very simple, guys. Please listen. An electronic component which transfers the signal from one resistance region to other resistance region is called as transistor. I'm repeating. An electronic component which transfers the signal from one resistance region to other resistance region is called as transistor. This is the exact definition for transistor. Someone given the answer, that is transfer the signal. Yes, sir. Transfer of signal from one resistance region to other resistance region is exact definition for transistor. So I'm repeating the same definition. An electronic component which transfers the signal from one resistance region to other resistance region is called as a transistor. Okay, guys, tell me how many types of transistors we are having. How many types of transistors we are having? I given the definition for transistor. And again, my question is, it is an electronic component which transfers the signal from one resistance region to other resistance region. How many types of transistors we are having? Most of the members, they are giving the answer as 2. And one person, Simranjit Kaurji, given the answer as 3 types. You tell me 2 or 3. If it is 2, what are those 2? If it is 3, what are those 3? Please respond, Nana. This is not a regular engineering college class or academic class. This is interactive class because it is the professional coaching. Gate coaching is always professional coaching. X. Deepakshi ji given the answer as NPN PNP. PSG also given the answer as NPN PNP. Yes, Simranjit ji given the answer as common emitter, common collector, common base. And Poti Jain ji given the answer as NPN PNP. Any other? Two only NPN PNP. Saroj Kumar ji. Yes. Oh, new answer. Saloni. Saloni ji given the answer as BJT and FET. Other are subtypes. Saroj Kumar ji given the answer as other. Yes. Basically, our transistor is 2 types, Nana. 2 types. One is unipolar. Second one is bipolar. One is unipolar. Second one is bipolar. First one is unipolar, and the second one is bipolar. I will take other page. Yes, I'm writing here, guys. Today, mainly, I will concentrate on basics itself. Yes, guys. First one is unipolar. First one is unipolar, and second one is bipolar. First one is, just listen. First one is unipolar. Second one is bipolar. What is unipolar? What is bipolar? The transistor in which current flows due to one type of charge carrier. One type of charge carrier is called as unipolar. It may be due to electron or may be due to hole. The transistor is Nandini Goyalji. Sir, there is background noises. Sir, not able to hear properly. What about others? Are you able to get my voice clearly? Please respond. Is my voice is clear or not? Not clear. Not clear means, is it getting breaking, or are you getting any noise? Achha. Actually, right now I am in a small cabin, adjacent of that one. Main road is there. That is the reason you might get vehicles, but for today's session, for today's class, please mind concentrate on my message signal only. That is voice, not a noise signal. That's my request only. Okay. Next class onwards. Yes, next class onwards, I will try to take the class in closed room uh, because we are facing noise problem. Okay, we are having two types of transistors. One is unipolar, second one is bipolar. What is unipolar? The transistor in which current flows only because of one type of charge carrier, either due to electron or due to hole, is called as unipolar transistor. I'm repeating, the transistor in which current flows due to only one type of charge carrier is called as unipolar, and the transistor in which current flows because of both the carriers, electrons and holes are participate in the conduction process, is called as bipolar transistor. Only either electron or hole is participate in the conduction process is called as unipolar. Guys, can anyone give the example for unipolar transistor? Guys, can anyone give me example for unipolar transistor? Example for bipolar, example for unipolar. Anyone in class? Yes, Manjot Singh given the example as MOSFET. Yes, any other? FET, FET. Next, guys, in today's class, I would like to discuss one excellent concept from this unipolar concept only. Yes, any other? Example for unipolar. Yes, Saroj Kumar given the example for bipolar. Excellent. BJT. Best example BJT. There is no other for bipolar, but unipolar. We have two components. Anyone? Anyone? If I take offline class, definitely for this question, I might offer gift. Unipolar FET, sir. Okay. One is FET. Second one, almost more than 30 members in my class. Yes, 32 members. Guys, what is the second example? Yes, most important, guys, UJT, Uni Junction Transistor. Here, I would like to discuss about UJT. Of course, UJT is not included for gate syllabus, but for engineering services, railways, UPSC and SSC, the syllabus is included. That is, UJT concept is included in syllabus. That is the reason I would like to discuss about UJT for few minutes. Please listen carefully. It is the unipolar component. And what is the property of UJT? It operates with a special property, Nana. Can anyone? UJT is having one special property. In universe, it is operating with one special property. What is that property of UJT? Property itself is unipolar. Saroj Kumarji. It operates with one special property. Can anyone guess? No. Okay. It operates with negative resistance property. If any possibility in your notebook last, please note down these important points, guys. UJT is the unipolar device. UJT is the unipolar device and it operates with negative resistance property. It operates with negative resistance property. It operates with negative resistance property. Guys, in universe, only two components are exhibiting negative resistance property. One is UJT. What is other component which exhibits negative resistance property? Can anyone? UJT is exhibiting negative resistance property. Along with UJT, there is one more component which exhibits negative resistance property. Can anyone guess the second component? There is one more component which operates with the negative resistance property. Can you answer it? Most important, guys. No, not transistor. No. Yes. I will give the answer. Tunnel diode, Nana. Tunnel diode. Tunnel diode. Tunnel diode. Please note down. Only these two components are operating with. These two components are operating with negative resistance property. One is UJT. Second one is tunnel diode. First one is UJT. Second one is tunnel diode. Yes, if any component is operating with negative resistance property, if any component is operating with negative resistance property, that is having the special application. Means this is the component operating with special application. Means it is having the one important application. What is application of the component which is having the negative resistance property? What is the application of UJT? Application of UJT is relaxation oscillator. Please note down. Relaxation oscillator. It is used for design of 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 relaxation oscillator. Please note down points. All these are most important, guys. Relaxation oscillator. Yes, we are having one circuit that is oscillator. Oscillator. And I given new name as the relaxation oscillator. What is the difference between these two? Oscillator and relaxation oscillator. Difference between oscillator and relaxation oscillator. Difference between oscillator and relaxation oscillator. I will give the difference, guys. Oscillator is the circuit which generates oscillating signal without any AC input or without any oscillating input. Here it is having the positive feedback, and this is the amplifier circuit. Coming to the relaxation oscillator. Relaxation oscillator is the circuit so guys, I'm repeating. In without any AC input with use of positive feedback. In relaxation oscillator, no input, AC output without feedback. That is the main difference. That is the main difference. Please note down this difference, guys, between oscillator and relaxation oscillator. For oscillator, input is nothing. There is no AC input, but output is AC with use of positive feedback. Whereas in relaxation oscillator, input is nothing, but output is AC, no feedback. That is the basic difference between oscillator and relaxation oscillator, guys. Yes, I'm explaining. Oscillator. Oscillator is the circuit which generates AC signal. Output is AC. For oscillator, output is AC without AC input. No AC input, no input, but it generates AC output. Oscillator generates AC output with use of positive feedback. With use of positive feedback. Whereas relaxation oscillator, no AC input, but generates AC output without feedback. Without feedback. That is the importance of relaxation oscillator. In oscillator, feedback existing. In relaxation oscillator, no feedback. Without AC input, circuit can generate AC output. Circuit can generate AC output, guys. Okay, that is the main difference. Especially in technical interviews, guys. I'm repeating, especially in technical interviews, technical resource person, they will raise a question as, can you differentiate oscillator from can you differentiate oscillator from relaxation oscillator? In that particular case, you have to give the main difference as, in oscillator, positive feedback exists. With use of positive feedback, circuit generates AC output without AC input. With use of positive feedback, circuit generates AC output without any AC input. Whereas in relaxation oscillator, without feedback, circuit generates AC output without AC input. That is the main difference between oscillator and relaxation oscillator, guys. Okay, coming to the output of relaxation oscillator. What is the output of relaxation oscillator? Output of relaxation oscillator. Output of oscillator is sine signal. Guys, actually, that's what I'm saying. I'm on the way. Directly, I'm coming from the office. On the way, in small cabin, I'm taking class today. Tomorrow onwards, I will take the class in my home. Okay. If you are getting more disturbance, I will stop today's class and I will start tomorrow. If you are facing my background noise is very high, then today I will stop the class. Okay, sure. I'm ready to take the class tomorrow also. But I have to. You have to spend 1 hour extra in tomorrow's. Tomorrow you have to stay in class extra 1 hour because today. Okay, no problem. Then. Okay. Actually, I'm adjacent, beside of road. That is the reason. While vehicles are moving, definitely we are getting little bit disturbance or noise. That is the main problem, sir. Guys, no issue. Tomorrow onwards, I will take my class in closed room itself. I won't create any problem. Okay. Today I'm stopping here. Sorry for inconvenience. Today I'm stopping here. Tomorrow I will take the class. Okay, thank you guys.